Hello, I'm Janvi Rana, and in this particular video, we are going to learn about single effect evaporator. Single effect evaporator is being used in sugar and paper and pulp industry. So, in this particular video, we will learn about single effect evaporator, its calculation, how to design, and know of its performance. So, let's get started. Over here, the feed enters into evaporator and gets converted into vapor and a concentrated liquor. This is being done with the help of steam. The steam over here is assumed as a saturated steam. As we know, in industry also we use saturated steam, as saturated steam provides the latent heat. So here the entire steam that comes into vapor form gets converted into liquid form, so giving the maximum heat transfer to our particular feed. Now let's do its calculation. So according to this diagram, we will have mass balance and energy balance. As we know, the amount of steam entering the entire one, it gets converted to liquid. So we have got ms equal to ms. But when you talk about feed, the feed flow rate mf equal to mv plus mp. So input equal to output. So input is your mf feed and your output is mv plus mp. Now when we're talking about energy balance, we know energy in equal to energy out. So in energy, what is the energy in over here? It is mf into hf plus ms into hs, that is the heat of feed and the steam, which is equivalent to the heat mv hv plus product heat, that is mp hp plus ms hl. So the this h is all the enthalpies of the particular feed and steam. Now doing calculating it, putting ms together, we get it is hs minus hv. So what is it? This is enthalpy of its vapor state minus enthalpy of liquid state. So this equals to lambda s, which is called as your latent heat of vaporization. So putting this together, we get the equation as mfhf plus ms lambda s equal to mvhv plus mpHp. So this is the steam's latent heat of vaporization. Okay. Now learning further. So based on this particular equation, this content, that is ms lambda is called as rate of heat transfer. This rate of heat transfer is equal to m lambda s, and equating putting mfhf on rhs side, we get this particular equation. At the same point of time, we know that delta t, the design q is equal to h lambda t. Over here, when we are taking all the effects into calculation, we get u, that is your heat transfer coefficient, a is the area of heat transfer, and delta t is the temperature difference. So as we have seen in design of heat exchanger, the delta t is generally the log mean temperature difference, but over here we have been using the saturated steam. So the delta t over here is defined as the saturated temperature of the steam minus TB, that is the boiling point of the solution. So over here the temperature difference is equal to TS minus TB. So this particular thing has to be remembered importantly during your calculation. So from this particular equation, we get the design equation of evaporator, that is q is equal to ua delta t, which is also equivalent to m into lambda s, that is latent heat of steam, which is also equal to mvhv plus mphp minus mfhf. So this is the design equation. So in case if you need know any of this parameter, delta t is generally known factor, you have to find it through theoretical values, and from that you can find a. With the help of a, you can design your particular evaporator. So this is what is called as design equation and heat equation of the particular single effect evaporator. Now going to next is learning about how does multiple effect evaporator perform. So what are the measuring performance parameters? So on this particular note, we have two performance parameter. The first is capacity and the second is economy. Now how do we define capacity? Capacity is defined as kg of water vaporized per hour. So kg of water, either it could be water or any of the solvent that is being vaporized. So this particular capacity gives helps to get to know about the sizing of the particular evaporator. For example, we have one that gets 10 kg per hour and another is 20 kg per hour, and other parameters being the same. So we can find that this 20 kg has higher capacity than the earlier one. Now, what is economy? Economy is kg of water vaporized upon kg of steam fed. So, and kg from all the effects like uh, your sensible heat, latent heat. So kg of water or your solvent that is being vaporized upon the kg of feed, say. Now, why knowing economy is important? Economy tells the heat transfer rate of the particular evaporator and whether fouling is occurring or not. For example, you have got one evaporator with economy of 10, as this does not have unit, and the second evaporator with the economy of, let's say, 30. So you can find that by feeding 1 kg of steam, you are able to only evaporate 10 kg of solvent over here. On the other hand, in the evaporator 2, you are from 1 kg of steam, you are able to evaporate 30 kg of the particular. So E2 has a higher economy, or you can say a higher heat transfer rate if other parameters are constant. And for example, let's say the evaporator 1 has 10 kg, and after a year of working of 2 years, it gets down to 5 kg per 1 kg. That is, the economy turns to 5, which means that it has lower heat transfer than what it was before. So this also signifies a practical problem of fouling in the particular evaporator. So by this particular two parameters, capacity and economy, you can know the performance of single effect evaporator. So I hope you got an understanding about the calculation of single effect evaporator, its design, and how to evaluate its performance. Thank you.